about 6% increase in the eddy kinetic energy in at least the Indian and Atlantic, Pacific sectors of the Southern Ocean. The Atlantic is not really changing as much. There is a variability, this biennial variability, and it's very interesting, and we're still doing some modeling studies. Andy Hogue is doing some modeling studies to try to understand this, is why the Atlantic is not changing as much as the Indian and the Pacific. Part of it is due to the fact that the winds, the Southern Ocean winds, are a little bit different in the Indian and Pacific than they are in the Atlantic. They're actually changing more in the Atlantic, in the Pacific and Indian than they are in the Atlantic. The variability is slightly different there. And so there is this evidence of this increase in the eddy kinetic energy. I'll talk about transport a little bit later at the end of the talk, hopefully, if I don't run out of time. But let's look at another aspect of work that we've been doing, and that's going back to the transport calculation. So remember with the previous discussion on the transport from combining the surface currents from altimetry and the Argo density data, we could only go down to 2,000 meters depth. But we know that there is a large contribution from the currents below that. Well, if we look at the transport calculation, what we would really like to have is the velocity at every location in the ocean, the geostrophic velocity, at every region in the ocean and at every depth. We don't have that. But if there was a change in the mean vertically integrated current, that would actually cause a change in the bottom pressure on either side of the current. And if we can measure that, then we could at least get that aspect of the transport variability that's related to the depth average current. And that would give us some information about what's going on in the deeper ocean that way. Well, we actually do have some global measurements of bottom pressure variability. I won't go into the details of how we obtain those measurements because that would be a talk in and of itself. But they're from a satellite mission called GRACE, which measures the Earth's gravity and how it varies in time. And in the ocean, the most dominant change in the Earth's gravity field is related to the bottom pressure fluctuations as the mass is redistributed in the ocean. It's very large scale. It has a lot of uncertainty. The error is very close to the signal. But through various processing techniques that I've developed over the past decade, we can actually eke out quantifiable measurements that have been shown by myself and numerous other researchers to be accurate. And so one of the things that we've done, and this is some work that Jessica Mikowski did for her thesis and that she's continuing with me, is to actually quantify how accurately we can measure transport variability in the Southern Ocean and the Antarctic circumpolar current using these gravity measurements. And I'll show you a few plots from this paper that's in review right now. So the point here is there's very high frequency variability in the transport. I don't know if you can see these error bars here, but those are based on a statistical model that we created that accounts for smoothing of the GRACE measurements, the basic signal scale of the GRACE measurements, and errors in the GRACE measurements. There's a lot of high frequency and annual variability, but if you do a low-pass filter, you can still see significant low-frequency variations, and that's what we really wanted to concentrate on, these low-frequency variations that may be indicative of long-term changes in the transport of the Southern Ocean, as well as these relationships with the variable winds in the Southern Ocean. All right, so the first thing we did, because we know that there is a relationship with the southern annular mode and winds between transport and in the Southern Ocean, we compared the GRACE estimate of the variable transport with the southern annular mode. It's a significant correlation, even accounting for the fact that the low-pass filter, but it's not a high correlation. And you can see some obvious places where the transport that we measure from GRACE varying is not the same as what the SAM says is happening. Probably the most dramatic one is right here. We know exactly what's causing that, though, and that's because Grace was not operating during that period and that period right there, right when we had the low in the SAM. And because of the way the low-pass filter works, it just averages between those, and that's why this has occurred. And that's because of some issues with Grace. It has old batteries. They have to turn off the instrument a couple of times a year in order to save the batteries. The same thing happened here. In the early part, when we were just starting the instrument, we didn't have all the variants, and that explains some of these differences here. But it doesn't really explain the differences right here, where Grace was operating continuously. And so I want to point out the difference here. It's a fairly dramatic difference. The SAM was much lower here than it was here in 2007 than it was in 2009, whereas the bottom pressure from Grace would suggest the opposite, right? The transport from Grace. Well, just remember, the SAM is only a proxy for the strength of the winds. It doesn't really capture the entire variability of the winds. What better captures the entire variability of the winds, and what actually drives the transport variability in the Southern Ocean, is the integrated wind stress over the Southern Ocean. And so a good indicator of that is just the zonal average of the wind stress over the Southern Ocean, which we can get from satellite observations. And if you compare those, you see a very dramatic difference. Now, note that the satellite winds that I'm using stop at the end of 2011. That's because QuickSat died in late 2011, and the newer satellites have not been operational yet, so the product has ended. But we see better agreement here at the beginning, and we also see that the winds support what Grace is seeing in the transport, that the wind variability low was less here than here, exactly like the transport that Grace is seeing as well. And the correlation, of course, supports that. All right, let's talk about trends. And this is very, very speculative, but it is based on 3 completely independent studies that I'm involved in. And it's very speculative, mainly because there's high uncertainties on all of these. They're over very different periods, and they're also over very different regions. Okay, so I'm going to try to talk through this real quick before I end. And so let's talk about this one from the Grace measurements from Jessica's work. This is only over the Indian Ocean and only over a sector of the Indian Ocean, basically the western sector of the Indian Ocean. And it's only between 2003 and 2014, but it is based on monthly observations, and we find a small but significant change in the transport of the Southern Ocean. But it's not increasing transport, it's actually decreasing transport. And so we've been trying to explain that for almost a year to understand this observation of decreasing transport. Well, during that time period, I started talking to Andy Hogue and Mike Meredith and Chris Hughes, and also Greg Johnson and Sarah Perkey at the University of Washington. And so we looked at this in completely different ways in these other 2 studies, and we essentially see the same negative trend. The magnitudes are very different, the uncertainties are very different, but we all support the fact that it looks like the transport, at least over these areas that we're looking in the Southern Ocean, has not increased over time. It has decreased over time over the last 20 years. All right? So I won't go into the details of this. If you have any questions, I can comment on it later. So what does it all mean? Well, I think what we have shown and what we do understand is that on interannual periods, the transport variability of the Southern Ocean is highly driven by the variability of the integrated winds of the Southern Ocean. That's not surprising. Okay? What is surprising is this change in the slowdown, this deceleration in the transport over the last 20 years or so, 10 to 20 years. We really don't know the mechanism for that. It cannot be the winds. The winds are increasing. but it may be buoyancy forcing. Okay, and so the buoyancy forcing is the changes in the heat flux and the changes in the water fluxes. Okay. We have very bad measurements of those quantities in the Southern Ocean. In fact, we have very poor measurements of those throughout the entire world because flux is very difficult to measure. We usually infer it based on bulk formula and measuring other quantities. Or we get it out of operational meteorological models. But Andy, in this paper, did a couple of simple sensitivity testing on his model, his eddy resolving model that he could run for a very long time. And so he looked at changing the winds in the model and then changing the buoyancy forcing in the model. Now, this was a very simple experiment. He didn't change the buoyancy forcing on just the southern limb and the northern limb differently. He did it over the entire region, so that may have driven some of the results, and we need to re-examine that. But his model experiments suggest that the transport in the Southern Ocean is much more sensitive to buoyancy forcing than winds. And that the eddy kinetic energy, on the other hand, is more sensitive to the winds on the long term than the buoyancy forcing, right? But that's just a sensitivity examination, and we need to study it a little bit more. So anyway, I'm going to end there, and do you have any questions? Not too bad.
We are a little behind. One question.
Just about your EKE anomaly.
Yeah.
The trend of increase seems less than the variability.
Yeah.
So is it that significant since it's only been a 20-year window that you've been looking at it?
So it's significant over the 20-year window.
Right.
We can't say if it's significant or indicative of a longer-term change. But within that 20-year window, yes, and the uncertainty, I did account for the variability, the internal variability. Yeah.
Let's thank Don again. And I think